Today I have something amazing to show you that I think very few people know about. We are talking about ISO tolerances and Siemens 840D control. Paolo, if I tell you 80G6, what are you gonna say? No, let's try again. 100H, 8. No, come on Paolo, we are not playing Battleship. These are the geometric tolerances in ISO format. And so it may happen that if you are in the workshop and on the drawing you find the nominal dimension, which in this case is 100, followed by the ISO coordinate of the tolerance, which consists of a letter and a number. The letter in this case is H and indicates the position of the tolerance range, and the number indicates its degree of accuracy. Usually then, in order to make the program, the workpiece itself or the measurements, we need a basic piece of information, which is the offsets. For example, for our 100H8, so capital letter for hole size, the tolerance offsets are +0 to +0.054. It means that my workpiece will have to be between 100 and 100.054 in size. To obtain these two offsets we usually go to tables or applications, which, by the way, can be found almost everywhere in the workshop. And we programmers and operators, except for special situations, will try to work trying to center the tolerance as much as possible. So in this case 100.027. But now comes the good stuff, or rather, here comes Siemens itself, which in fact has done a really useful thing. If we enter for example a pocket cycle, in the field where we go to indicate the pocket diameter or possibly other fields where there is a dimension that may be subject to dimensional tolerance, pressing equal, which usually simply brings up the calculator, in this case has two other features, a calculator for hole tolerances and one for spindle tolerances. Let's take our case from before, so our hole. In the first field we put the nominal value 100, then the field position corresponding to the letter, so in our case H, and finally the number for the accuracy degree, so 8. Pressing calculate will bring up the value of the average dimension to be written directly into the cycle, so the dimension that is exactly in the center of the tolerance, which is the one we should usually program to avoid in machining. For example, acting on the wear of the cutter radius. To enter that value directly into the field, press accept, and there you go. Well, I would say that it is a very good tool that does not completely replace apps or tables, because the need to know the offsets still remains. But it certainly makes it easier to calculate the average offset, and most importantly it saves us from struggling to enter digits with decimal numbers into the program.